before you can run an NMR spectrum, you have to dissolve the organic compound into a deuterated solvent. So what is a deuterated solvent? So for example, if you have methanol, this is methanol, you replace the hydrogens in methanol with deuterium, because deuterium has a different frequency as compared to the proton. So in other words, you will not be able to see these protons, which may interfere with your proton NMR spectrum. So once you do that, then you place your organic compound in this sample tube, and then you place the sample tube in this machine here, which is between two magnets, and then you apply radio frequency, which is transmitted through this compound, and it's absorbed by the compound. And then the detectors monitor the absorption, and then they're able to give you an electronic signal, which is amplified and displayed as a peak, and then we get the NMR spectrum. So this is what we're going to learn how to interpret. So here is an example of an atom. Now within this atom, we have electrons which surround the nuclei. Now when you apply an external magnetic field to this atom, the electrons, these electrons that are surrounding the nuclei, they set up their own tiny local magnetic fields. Now these local magnetic fields are usually in opposition to the applied magnetic field, such that what the nuclei feels, or the actual effective field felt by the nuclei, is a bit weaker than the applied magnetic field. And this is due to the fact that you have opposing magnetic fields, the local magnetic field opposing the applied magnetic field. Now, electrons in bonds, so if you have, remember, a bond is made up of an electron from this carbon and another electron from this carbon. So these electrons in a bond shield the nuclei from applied magnetic field. So if you look at a compound like this is ethanol. You can see that each nuclei, in other words, the protons here and the protons here, and this proton are all in different electronic environment. And therefore, each nuclei, that is over here, over there, here and there, is shielded differently. So nuclei that are further away from the electron withdrawing groups are said to be shielded, whereas those nuclei that are closer to the electron withdrawing group are going to be de-shielded. So you can think of shielded and de-shielded like this. So remember, in any atom you have electrons which are protecting or covering the nuclei. So if you have an electron withdrawing group closer to this nuclei, electron withdrawing groups pull electrons towards themselves. So because they're pulling electrons towards themselves, if you look at it in this picture, it's like they're removing these electrons which are supposed to be covering the nuclei. And by so doing, if they're removing the electrons, it means they are exposing the nuclei. And therefore we use the term de-shielded, or we say, in other words, you can think of it as the nuclei is exposed. But if you have this nuclei here, which is further away from the electron withdrawing group, that means not so many electrons are pulled away from it, and therefore the nuclei is being covered or protected, and we use the term shielded.